Hey guys, so today we're going to continue with the atomic structure and our standard on representing atoms and atomic structure in our South Carolina standards. So we are going to focus today on how we represent these atoms of these elements and how we can pull needed information from the symbols. So, before we leave our lesson today, we need to be able to answer two essential questions. We need to be able to explain how atoms are represented in symbolic form. So, we are going to show that we can do this by being able to take given information of an atom and placing it in the correct format for our symbolic representation. The other thing we need to make sure we are able to do is to make sure we can look at that nuclear symbol and pull the information provided in that symbolic representation. So these are the two questions we should be able to answer at the end of this lesson. All right, so we have been working with some of this vocabulary already. So, three of the words we should already be able to define and clearly understand: proton, neutrons, and electrons. So, in our previous lessons, we're looking at what a proton is. It's the positive charge found inside the nucleus of an atom. Neutrons, they're the neutral charge. They're also housed, remember, in that nucleus. And then the electron, which is the negatively charged particle, and that is found on the outside part, floating around there in the electron cloud. Four new terms you're going to learn today in our lesson: nuclear symbol, mass number, atomic number, and charge. So we'll revisit that at the end of the lesson to make sure we can clearly define those terms. Okay, so here is part of a lesson that I taught live. So this was all incorporated under these standards and the essential questions. I just included it here because it was already recorded on YouTube live in front of a class. So I did shorten it a little bit to fit within the time constraints of the email that you guys sent me. And then also so that it protected the students who were live on this lesson. So I'm going to hit play. This is the meat and potatoes of the lesson and of the content within that standard.
Okay, so this brings us to how we represent atoms when we're talking about their atomic structure, when we're talking about how to represent them in a chemical reaction or in a nuclear reaction. How do we do this without having to write down paragraphs explaining all of the things that are going on with that atom? So we do that in chemistry with symbolization. All right, so we are going to symbolize our atoms, and it's going to give us all the information we need to know about that atom. It's going to tell us what its symbol is, what its mass is, what its atomic number is. It's going to tell us a bunch of things. And it's all done in a very short, compact method that we're not writing paragraphs explaining about the atom. So the first thing that we're going to look at is how to draw or write the nuclear symbols for the atoms of interest. So I have a sample atom up here at the top corner that I went ahead and already wrote down. We're going to look at the sodium atom. And the sodium atom, this particular atom, has 11 protons. Okay, that's what the P stands for. 11 neutrons and 10 electrons. So we're going to represent this atom in a nuclear symbol so that we have all of that information in a real compact place for when we're looking or observing it, how it reacts, and that kind of stuff. All right, so the first thing we need to do is we are going to write it in the form that is shown below. So this layout here is how we represent atoms using the nuclear symbols. You can see here we have the X. That big X represents the elemental symbol. It's found on the periodic table. It is either a 2-letter or 1-letter symbol. Not all of them kind of at first makes sense. So if you look at sodium, it has Na. So a lot of the symbols that they derived for each of these elements came from their Latin name. We're not going to get in to what all of their Latin names are, but that's why some of their symbols don't match up with their actual name. So Na is the symbol for sodium. So if we're going to write this in its nuclear symbol, we're going to put Na in the center, just like the X is right here. All right. The next thing we're going to do is we're going to include at the top the Z. So the Z represents something called the mass number. The mass number in an atom is the mass of that particular atom. So remember that the mass comes from only two subatomic particles. It comes from the proton and the neutrons that are housed in the nucleus. Because remember, the nucleus is very small and it doesn't take up much volume in the atom, but it makes up all of its mass. So to find mass number, all you are doing is adding the number of protons with the number of neutrons, because that is what is housed in the nucleus. So mass number is representing that weight of the nucleus. So only the things in the nucleus can be added to get the mass. Okay, so mass number is protons plus neutrons. So for the particular atom we're looking at, we are dealing with 11 protons and 11 neutrons. So that means its mass number is going to be 11 plus 11. So we are going to have a mass number for this particular sodium atom as 22. So I'm going to put that as a superscript in the upper left-hand corner. All right, so the next thing we need to add is the A. Okay, now the A represents the atom's atomic number. Now, if you take a look at your periodic tables, you will see that the atomic number is it'll either be in the upper right-hand corner. On some periodic tables, they're right smack dab in the center, and then other times they're going to be below the atomic symbol, right there in the center. Okay. So one thing you'll notice is that each element is assigned its own atomic number. And if you change the atomic number, you change the element. This is a very important piece of information that you need to keep in your brain. It needs to be something that's locked in there, because the atomic number represents the number of protons that are found in the nucleus. So if you change the number of protons, you change the element. So theoretically, we could take any element and we could change it into gold by just making it have 79 protons. So that's theoretical. We're going to get into why that's not super feasible, why it's not something that we do, because it takes a lot of energy to do that. And we're going to discuss that as we're moving through the atomic structure. But the number of protons is going to give the identity of the element. So if you change that number, you change the element. So the atomic number for sodium is 11. Okay. When we're looking at this, remember, okay, that's also how many protons that element has. So sodium has 11 protons, which is its atomic number 11. So we write it right below the mass number. Now the next thing you can see here in the upper right-hand corner is the charge. So how do we get charge? Okay, well, charge is really easy to find, because all you do is you take, to find charge, you are going to take the number of protons and you're going to subtract it from the number of electrons, because remember when we discussed about the subatomic particles of the electron and the proton has a +1 charge and the electron has a -1 charge. So they are going to cancel each other out to make a neutral or zero charged element. So if I have an odd number of protons or an odd number of electrons, it's going to give the overall charge of an atom its positive or negative charge. So it's going to create these things called ions. So in this case, if you look for charge on this sodium atom, There are 11 plus charges in the nucleus, and there are only 10 negative charges in the electron cloud. So what happens is it gives this atom an overall positive +1 charge. So I can write it like this. Now, sometimes you will see when we write charges, especially when it's a 1, sometimes that 1 is understood. So sometimes you're going to see it written just like that because that 1 is understood. All right, so that's how we calculate charge. We are going to look at the number of protons versus the number of electrons. And if there's different numbers with that, we have a charge. So that is how we write nuclear symbols for atoms. Now, one of the neat ways when we're looking at this is when you're looking at a nuclear symbol like this, it's very easy to determine how many neutrons are already in that atom. So if I was not given the information up here, I could figure out all of that information by just looking at this atomic symbol because everything we need is right there. All right, so let's look at this. So if I wanted to know how many protons, neutrons, and electrons were in this atom here, first off, the number of protons, well, that's easy because remember that is always the atomic number. So that number always matches the number of protons that you have. So that would be 11. With neutrons, well, neutrons are housed in the nucleus with the protons. So I know I have 11 protons. I know that the mass of my nucleus is 22. So if I take the number on top and I minus it from the number on the bottom, that's going to tell me how many neutrons there are. So this tells me right here. To get that, I just take the mass number and I'm going to minus it by the atomic number. And that will always give you the number of neutrons found in that particular atom. So 22 minus 11, I have 11 neutrons. Now for electrons, the charge is going to tell me that. The charge is going to help determine how many electrons. The charge, again, tells you that I took the number of protons and I minused it from the electrons. Well, if I have a +1 charge, that's telling me right there that I have one more proton than I do an electron. So you could either plug it in to charge is equal to proton minus electron. You could plug it in and solve that way. Or you can just think about it in your head. Well, if it's a +1 charge, there's one more proton than there is an electron. If I have 11 protons, that means I'm going to have 10 electrons. Okay? We're going to do some more practice with this later on. Okay, so this brings us to how we...
Okay, so at this point in the lesson, once I had taught all of that content, I would utilize breakout rooms. So we in my district use Google Meets and Google Classroom. And in that, we have the option in the Google Meet to create breakout rooms. This is where I'm going to create my small groups to work with them one-on-one on the content that was just presented. So what I would do, especially with the list of students and the data from the students provided in the email, the way I would for this lesson divide my students up in their small groups is I would keep the advanced students together because this is a topic, after teaching this for 12 years, this is a topic that they grasp pretty quickly. And I would keep and divide to have two groups of my proficient students. I would provide two groups for them. So I would divide them up in half. And then I would divide my non-proficient based off of how based off of the IEP, actually, because this is very math heavy. And with students who need help calculating, they need a little bit more scaffolding. So I would keep them in a group together. At this point in the lesson, so what I would instruct the students that they would be doing is I would start the breakout rooms. With the breakout rooms, they have something called Jamboard, which is like a whiteboard. And they would have some questions already ready to go when I set the break rooms up, that the questions would be there and on their screens. For my advanced group, they would first discuss the essential questions. So the directions for these breakout rooms is I would have them one. I would have this slide on the Jamboard, so when they go in the breakout room, they would be able to see this. Their instructions would be in a group, discuss the how you would answer the two essential questions from the content presentation, and also to come to a conclusion, a consensus on how you would define the vocabulary words. And then there would be two sample problems that they would solve together. They would have one where they were given an element, given the number of protons, neutrons, and electrons, and they would derive the symbol for that particular atom. The second question that they would practice would be one where I gave them the symbol and they're going to tell me how many protons, neutrons, and electrons are in that atom. So they would all have in each of the individual small group breakout rooms, they would have that information on the Jamboard. And then I would be popping into each small group and scaffold as needed. I would expect that the advanced students would go through it very quickly, be able to ask questions, and then I would gradually release them into their individual practice or independent work, which would practice these skills. So it would be a couple more problems where they are either forming the nuclear symbol or pulling the information out of the nuclear symbol. For my medium levels, the two medium level groups, they may need to ask a few more questions and have more clarification, but I would definitely be checking with them to make sure that they could clearly answer the two essential questions, define the vocabulary, and were able to come to the right answer on the two sample problems before gradually releasing them into into their independent practice. For my non-proficient groups, so they would definitely need more one-on-one time with me, and that's why I like to set them up into these breakout rooms so that I can provide that feedback as they're working on it. And I would be popping in um, each of these. I would not be spending all the time with one group and not seeing the others. I would be facilitating to make sure that they're working through the problems and that they had the information to continue on. I would expect to spend more time with the students who needed the help with the calculations and or the reading comprehension. And then once they were able to answer the essential questions, once they were understanding how to pull the information out of the nuclear symbol and how to draw the nuclear symbol, I would release them into the independent practice. I would expect for my students who needed help with the calculations that we would have to do a few more problems together to make sure they were able to work on their own and without getting frustrated and just completely giving up. But that is how I would run the lesson for this particular content area.